Hello students, I am Dr. Nimi Singh. Today I bring you the next learning episode in BSc Forensic Science on an important unit of paper Technological Methods in Forensic Science, that is the forensic photography. This particular unit is divided into three parts. Students, in today's lecture, that is Forensic Photography Part 1, we will be studying about photography, history of camera and photography. In addition to it, you will also be told about how light is important in the field of photography and will also be introduced to some important terminologies pertaining to this field. We will then wind up today's lecture with a conclusion. Dear students, let us have a look at the modules which we are going to learn today. The first one is obviously going to be the introduction to photography. Then we will study the history of camera and photography, then light, then some terminologies used in photography, and then in the end we will conclude. Let us first come to the part 1, that is the introduction to photography. The word photography comes from the Greek word photos, that means light, graphos means writing, meaning writing with light. The word camera is also derived from another Greek word kamera, meaning anything within an arched cover or enclosure. A room is called kamra in Hindi. Photographic camera is a light tight box with light sensitive material, that is a film, at one end and a lens or a pinhole to admit light on the other end. Therefore, photography can be defined as the art, science and practice of creating the durable images by recording light or other electromagnetic radiations, either chemically by means of a light sensitive material such as photographic film, or electronically by means of an image sensor. In crime scenes, the documentation of the evidence is one of the most important stages of any crime scene investigation. Besides others, photography is considered as one of the important documentation technique in the field of forensic science, which can record the whole crime scene area, exact conditions of the crime scene and the evidences present over there. Photography is also sometimes used to further enhance the details that are not being visible to the human eye. The forensic photography section supports the forensic science in general, but to various divisions like question document chemistry, toxicology, ballistics, physical section, biological section, DNA and medical examiners departments by documenting evidence, crime scenes and autopsies, etc. Specifically, the photography section of any laboratory is also responsible for the design of displays and graphics for reports to be presented in the court of law, training and the web. So, this division is considered to be an essential part of general crime scene investigation and thereafter in the laboratory. Let us come to the history of camera and photography. Mosu, China approximately 500 BC, and Aristotle from Greece around 384 to 322 BC observed the formation of inverted image when light passed through a pinhole, and both of them investigated it independently. At the beginning of the 19th century, the first use of chemistry for photography was done by Thomas Wedgwood. He made negative by placing a drawing on glass or on paper previously treated with silver nitrate solution and finally exposing it to the sunlight. He also tried to record image with camera obscura, but in vain, as silver nitrate was not sensitive enough. His negative was not permanent. William Henry Fox Talbot in 1835 independently produced a light sensitive paper by bathing it first in common salt, and when dried in silver nitrate together, the chemicals formed silver chloride. On this treated paper, he made contact prints of things like lace and leaves, what we call photogram today, and the prints were fixed in common salt solution or with the solution of potassium iodide. Tabit's photogram was of course negative, but he soon evolved a method of reversing them to form positive by printing them onto a second sheet of sensitized paper. Sir John Herschel, Tabit's friend, termed the first picture as negative and the reversed one as positive. It is the fundamental principle of modern photography. By the advice of Sir Herschel, he adopted a more permanent way of fixing by using hyposulfite of soda to wash out unexposed silver halide. By using potassium bromide instead of common salt, he made more sensitive emulsion. In 1840, he modified the process, which was first called calotype and later tabotype. In 1888, George Eastman first introduced Kodak camera, which was laden in factory and developed in the factory after exposure. In 1889, Eastman introduced to public the transparent celluloid film, which could even be processed by the amateurs. Even with the passage of time, various developmental work continued on paper, films, photographic chemicals, lenses, cameras and other specialization related to the present day modern photography, even when the digital photography have been evolved, surpassing the age old paper, film and chemical processes. All of these we will study in our subsequent lectures, but today in this lecture, let us understand light before understanding the parts of a camera, because photography is not possible without light. Coming to light. Light is a form of energy which helps to see the objects in the material world around us. That is, it is a link between the eyes and the viewed objects. Visible light waves, which are the only waves which we can see from the complete spectrum of the electromagnetic waves. We see these light waves as the colors of the rainbow. Each color of the rainbow has a particular wavelength. Red has the longest wavelength, while violet has the shortest wavelength among the 7 colors of rainbow. That is VIBGYOR. VIBGYOR is seen when the white light is split into its component colors when it passes through a prism. This phenomena is known as dispersion of light. In the atmosphere, the formation of rainbow can be seen at times when water vapors act as prism for the light that breaks apart wavelengths, which creates a VIBGYOR. The colors are violet, indigo, blue, green, yellow, orange and red. Before violet, there is an invisible ray called ultraviolet, and after red, the invisible ray is called infrared rays. These invisible rays can also be detected by photographic plates or films. A typical human eye can see light from 400 nanometers to 700 nanometers of the electromagnetic spectrum. This range is called visible range. Not all colors that human eyes can distinguish are in the visible spectrum, such as brown, which is a mix of multiple visible spectrum colors, although photography is possible even in non-visible range of electromagnetic spectrum, such as in ultraviolet and infrared regions. The wavelength of various colors of the visible spectrum is given in the table below. That is the color and the wavelength. Red, it is 622 to 780 nanometers, orange 597 to 622 nanometers, yellow 577 to 597 nanometers, green 492 to 577 nanometers, blue 455 to 492 nanometers and violet 390 to 455 nanometers. When we have now studied about light, it is time that we move on to the study of certain factors that are to be complemented with light. That is illumination or lightning conditions. Illumination or lighting conditions make a significant difference between a photograph which is of good quality and the photograph which is of poor quality. When the natural light is not sufficient or it is not available, then we have to opt for an artificial light. Artificial illumination sources include arc light, flash bulb, electronic flash, etc. They can be moved and positioned accordingly so that various angles of illumination can be obtained. Control of the illumination angle is difficult when available light such as sunlight or normal room light is being relied upon for the exposure. Thus, Artificial illumination is preferred when control of the angle of illumination is important. For this, one should try different angles if it is not sure which of the illumination angle is to be used. Now coming to contrast. Contrast is the degree of difference between black and white or dark shadows and bright highlights of the photographs or images. Without contrast, there wouldn't be any difference between light and dark. There are two types of contrast in photography: high contrast and low contrast. An image is said to be in high contrast when it exhibits a full range of tones ranging from black to white, and strong, bold colors and textures of the images are emphasized. On the contrary, in a low contrast photograph appears dull as it does not exhibit a great deal of difference between its dark and lights. Best examples of low contrast are the photos which are taken in the fog or mist. Contrast in forensic photography is very important. Light sources play significant role in providing contrast. Coming to temperature and color balance. It is well known that white light is made up of all 7 colors of visible spectrum. The color of the white light used in color photography is critical. Color contrast filters are required for black and white photography. However, all sources of white light are not the same. For example, the light given off by a candle contains a higher proportion of the longer wavelengths corresponding to yellow, orange and red color. Hence, light appears yellowish or yellow white. While the light produced by a tungsten filament in a normal incandescent lamp bulb also contains a preponderance of longer wavelengths, although to a lesser degree. This light appears whiter than that from the candle flame, but is noticeably yellow as compared to the sunlight. The tungsten filament is hotter than the candle flame. There is a direct correlation between the temperature and the color balance. For example, the hotter the incandescent light source, the whiter the light it will produce. This relationship between the color of the source and its temperature specifies the degree of whiteness of the source by comparing it to the color of the light emitted from a standard source. Coming to the various terminologies used in photography. The first one is the films. The heart of the film is a transparent plastic material, celluloid, called the base. The backside of the film is generally shiny and has numerous coatings that are important for physical handling and processing of the film. The other side of the film is the sensitive side, where the photochemistry happens. There are 20 or more than 20 separate layers coated in the film that are mutually less than 1/1000th of an inch thick. Most of this thickness is consumed by a very special binder called gelatin that grips the imaging components together. Part of the layers which are coated on the transparent film don't form images. These layers which don't form images are present to filter light and to control the chemical reaction which occurs in the corresponding steps. Submicron sized crystals of silver halide are there in the imaging layer that act as photon detectors. These crystals are supposed to be the heart of the photographic film, as they undergo a photochemical reaction when exposed to various modes of electromagnetic radiations, that is light. Generally, there are 3 types of films. Film speed. Film speed is a unit to express the sensitivity of the films towards light. This means how much amount of light is required by a particular film to give a standard exposure. More sensitive films take fewer amounts of light and time to create an image in a particular lighting condition. The main units to express film speed are ASA, that is the American Standard Association, ISO, International Standard Organization, DIN, Dewey Industries norm. More sensitive the film, less the amount of exposure is required for taking a photograph, and vice versa. More sensitive the film or higher the film speed, the picture becomes more grainy, and lower the film speed, sharper the picture. Generally, films are categorized as per their film speed as follows. The film speeds: 12, 25, 50 will be slow speed films, 100 to 200 medium speed films, 400 to 800 high speed films, 1600 to 3200 ultra high speed film. The difference between slow and fast film is the quality. Slow speed films usually produce sharper and more detailed image, while faster films have higher contrast and grains. Film speed is very important while calculating exposure of photograph or the power of an electronic flash gun. Earlier, the camera exposure meter worked according to the film speed setting of the camera. Once a film of a particular speed is loaded in a camera, all the photographs are to be exposed, calculating exposure according to that particular film speed. Today, in digital photography, we can change the film speed or the sensitivity of the sensor even for every frame just by pressing a button or a dial. Exposure. Exposure is the amount of light required to create a standard image on a photosensitive medium of a given sensitivity. Exposure is the combined effect of the light falling on the photosensitive material, that is the film, and the sensitivity of the film, that is the film speed. The effect of the light falling on the film can be controlled by aperture and shutter speeds. The sensitivity of the film is another controlling factor for the exposure, which is called film speed. So, technically it is the joint calculation of intensity of light and its duration. Then coming to aperture. Aperture is an opening in between or at the back of a lens which controls the amount of light coming through it. It may be fixed or variable. Bigger the opening, more the light, and smaller the opening, less the light falling on the sensitive material. This is one of the devices to control the exposure of the film or digital medium. It is expressed as f number, and every next bigger aperture gives double the amount of light. Evaluation of the opening of the lens will vary the amount of light passing through the lens. If we increase the aperture or reduce the f-stop number, more light will pass through the lens. Every step towards higher f number halves the light, and every step towards smaller f number, that is bigger hole, doubles the amount of light. So, if we take a photo with a bigger aperture than required, more light will reach the photosensitive material and the photograph will become brighter than a standard exposed image, and if it is smaller, it will become darker than the normal. Standard apertures are f by 64, f by 32, f by 22, f by 16, f by 11, f by 8, f by 5.6, f by 4, f by 2.8, f by 2.0 and f by 1.4. Then comes the depth of field. One more thing that is intricately related to aperture is the depth of the field. Depth of field refers to how much of the picture is in focus. When we focus the camera lens to give a sharp image of a particular subject, other objects closer or far away in the photo are going to be out of focus if they are at a different distance from the focused subject. The decline of the sharpness for a particular f number of other objects is gradual. A shallow depth of field means that only the subject is in focus while everything else is out of focus. A deep depth of field means that everything is in focus. But for our practical purposes, we select a zone in front of and behind the focused subject so that the blur in this zone is too small to be noticeable and can be accepted as sharp. This zone is called depth of field. So, the aperture also controls how much of the photo is in focus. If the aperture is small, then everything will be in focus, while a large aperture will make objects blurred, even slightly far from the subject. Shutter and shutter speed. Shutter is a part of a camera which blocks or restricts the light from entering the film plane and exposes the film. The mechanical or electromechanical system for controlling the time during which light is allowed to reach the light sensitive material in a camera, that is film or digital sensor, is known as shutter. It consists of some means of covering the image created by the lens, opening or uncovering for a predetermined duration of time and covering it again. It can be activated by releasing the shutter release button. There are mainly two types of shutter: diaphragm or leaf shutter, focal plane shutter. Now, diaphragm or leaf shutter was devised by Mr. Friedrich Deckel of Germany in 1912. This type consists of 3 to 5 metal blades which can open outwards, leaving a clear hole for exposure and covers again after a preset time. The speed is controlled by pinions and levers. This type is generally mounted in between the lens components. William England in 1861 invented the focal plane shutter. It consists of one or more roller blinds of fabric or metal having a generally variable slit which moves across, inside, back of the camera just before the film or the sensitive material when the release is pressed. It may move up and down and across from left to right or vice versa. When exposure time begins, the first curtain is to release to start its travel. As it moves, the first curtain passes across the film frame, allowing light to fall on the film. When the first curtain has completed its travel, the frame is fully opened. When exposure time ends, the second curtain is released to begin its travel and close off light to the film. Shutter speed is the duration of time generally expressed in seconds, during which any type of shutter remains fully open for exposure. This excludes the opening and closing time, which is considered to be negligible. Along with the aperture, shutter speed indirectly controls the light falling on the sensitive material. The standard shutter speeds are 1 by 2000, 1 by 1000, 1 by 500, 1 by 250, 1 by 125, 1 by 60, 1 by 30, 1 by 15, 1 by 8, 1 by 4, 1 by 2, 1, etc. in seconds obviously. So, here also every shutter speed mentioned provides half the amount or duration of light in relation to the speed to its right and double the amount or duration of light in relation to the speed to its left. That means a shutter speed of 1 by 60 seconds gives half light as compared to 1 by 30 and double as compared to 1 by 125. Now, let us come to the difference between fast shutter speed and slow shutter speed. In fast shutter speed, the object is freezed and slow object is blurred. Therefore, the correlation between the shutter speed and aperture size is a direct one. Since aperture and shutter speed, both of them controls the amount of light reaching onto the film, let's slip from mind about the elements of depth of field, action, freezing or movement. And since both doubles and reduce in a scale of one time, that is 1x or 100%, it means you can freely interchange the settings on shutter timing and lens opening for respective effects and yet retaining your preferred exposure settings. This factor is constant when we consider the film speed to be constant. Let us finally come to the conclusion of this lecture. Photography can be defined as the art, science and practice of creating the durable images by recording light or other electromagnetic radiations either chemically by means of a light sensitive material such as photographic film or electronically by means of an image sensor. In crime cases, the documentation of evidence is one of the most important stages of any crime scene investigation. So, this division is considered to be an essential part of the general crime scene investigation and thereafter in the laboratory. Hence, the basic knowledge of photography and camera is required for investigation purposes. With all these information, here we come to the end of today's lecture. Do keep in mind what we have discussed today. I will be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs, etc. Thank you for your time today. I will see you in the next lecture. Have a great day.